Hello, this is Dr. Jack Jackson, and I'm going to be talking a little bit about mathematics in the 18th century in this playlist. As I usually do, I start out my playlist by referencing some of my major sources, and as always, I work with the lectures of Todd Timmons, my friend and colleague who taught history of math for many years. He graciously allowed me his materials. I look at two textbooks, History of Mathematics by Carl Boyer and A History of Mathematics, an Introduction by Victor Katz. And then also this wonderful online source, the MacTutor History of Mathematics, which has biographies of uh, hundreds and hundreds of mathematicians and other um, mathematical topics that it talks about. And I have other sources as well, but those are the main ones. So let's start by talking about an overview of the mathematics in the 18th century. So the pace of mathematical creation, discovery, development, whichever word you want to use, generally has increased over time with each year, each century, even being more mathematics than developed in it than the previous century. But the 18th century in particular saw an explosion of the rate of mathematical growth. And this included some of the most significant advances in mathematics that we've seen. Certainly the most significant that we'd seen to that time, with maybe the exception of just the founding of calculus. And many very prominent mathematicians lived and worked in the 18th century, including several that rank among the best of all times. They were able to expand on previous knowledge and they developed new ideas. These ideas led to the creation of entire fields of modern mathematics that are active areas of research today. But much of the advance in mathematics of the 18th century was driven by this new area of calculus, which was created in the last decades of the previous century. And so, for a century after calculus being created, invented, discovered, for a century, calculus was vigorously expanded and applied as a powerful tool to solve many problems. At first, these were in the physical sciences and later in other areas. And this further drove significant advances in many areas of science. These mathematical advances fueled the scientific revolution, which was basically set in motion by some of the same folks. Sir Isaac Newton, in particular, was credited with being one of the main instigators of the scientific revolution. The scientific method became a basic thing, and this various idea of looking at the world in a scientific way became very important, and that helped also to lead to the Age of Enlightenment. And that together, the scientific revolution, the Age of Enlightenment, helped influence all areas of intellectual thought, not just mathematics and science, but included all kinds of ideas, philosophy and in many other areas, literature and so forth. And these included ideas that led to some certain ideas like the revolution that happened in America with the founding of the United States of America, and later on the revolution in France and the creation of the modern democracy. And so all of these were fed in no small part by the advances in mathematics and science. So many scientific problems were solved using the tools of mathematics, and so many of them, in fact, that the notion that the world could be adequately described by mathematics and science, and that we could use these tools to predict the behavior and nature of science, that idea became the norm. And science had triumphed over superstition, and the modern age of mathematics and science was going full steam in the 18th century. So during the 16th and 17th centuries, European nations began to explore the world, and this need for exploration led to advances in making ships and working on techniques for navigation and other areas. Some of it was made possible by mathematical advances, and with the increased uh, seafaring travel, lots of things happen in terms of expansion and connection among peoples. So one of the things this led to more connections among different peoples. Mathematical and scientific ideas were now being transmitted throughout the world. European mathematics, for example, was spread to Asian countries. And this transformed mathematics in countries, say, such as China, that we studied quite a ways back. And so the more ancient Chinese way of looking at things, the medieval advances, was now being supplemented and in some cases supplanted by this European approach. In particular, the nations of Portugal and Spain became very early leaders in the exploration of the world and the growing colonization of new areas, including in the Western Hemisphere. Unfortunately, typically supplanting and subjugating the indigenous populations. Other nations vigorously joined in the European colonization, and most notably the Dutch, the French, and the English. And by the 18th century, really even by the beginning of the 18th century, there were well-established European colonies throughout the world, and even more being established through the 18th century. In the 1770s, the British colonies in North America revolted and formed the United States of America. In the 1790s, we saw a similar revolution in France, overthrowing the monarchy there. Both of these revolutions were fed by the ideas from the Age of Enlightenment, which we've already talked about being fueled, at least in part, by some advances in mathematics. Here's a map on the left of Europe around 1700, and you can see some of the things that are going on in Eastern Europe, very Eastern Europe. We have Russia, Poland, Lithuania there. The Ottoman Empire is going strong here uh, in the eastern part of Europe and into Asia Minor there. Uh, the Habsburgs controlled vast portions of Europe, including this area here in Hungary. Uh, France, Spain was here. Notice that Spain had at that point had control over the southern part of Italy and Sicily and some other areas around here. England and Ireland are here, Scotland up here, and so forth. Over here you see a map of just a few years later in 1740. Looks very similar. Austria and Hungary are here. A lot of this portion in here that's white over here and yellow here are smaller German states. So what was formerly the um, Holy Roman Empire really is now a collection of smaller groups. And this one here is notating several areas that became centers for the Enlightenment, including a couple in what were at that point British North American continents, today the United States, Boston and Philadelphia. We have important centers in Dublin, Edinburgh, London, Paris, Madrid, and so forth, including St. Petersburg, which is going to eventually become a very important mathematical uh, area later on or during this century. Switzerland becomes an important area for some mathematicians. France is a big area for mathematicians, with Paris being a big center. Berlin is also an important center, Vienna, and so forth, and of course London as well. So there's lots of different areas here that became important for the Enlightenment and also important for the development of mathematics. This map is around 1700 as well, but it's a more global view, and you can see some more layout here. Notice that the Ottoman Empire, this is a Muslim empire, it is going strong, and it has lots of North Africa, all of Asia Minor there, present-day Turkey, well into the Tigris and Euphrates River Valley, and into the Grecian Peninsula and beyond. So this is a very powerful and large empire that stayed for a very, very long time. In fact, even into the early 20th century as well, I think. And then this is there's the Europe that we looked at, but notice Russia has expanded. So Russia has expansion interest as well as some of these other countries, but it's mostly land-based as they go all the way across the whole northern part of Asia here. And you see, of course, there are important countries in China and India and elsewhere. Over here in the Americas, we see colonies of Europe. We see this huge light green area here is New Spain with present day Florida and Baja California here, to Mexico and Central America, down into Southern America. Um, Portugal had control here, Portugal there, but had control over what's present day Brazil, a little bit beyond that here along the coast in South America. The French had control of Canada and down the Mississippi River to Louisiana, and some other places around here, different places here, in Haiti and some other places. And then we have British colonies here in North America and some other places here. British in later centuries would expand their colonialism to have a very vast empire a little bit after this. And of course, these British colonies here are eventually what became the first parts of the United States of America. Now, what about math now? Okay, the development and expansion of calculus was really the centerpiece, really, of the 18th century. By 1670, previous century, Newton had developed all the main pieces of differential and integral calculus, and he knew the fundamental theorem of calculus. By the end of the 17th century, both Newton and Leibniz had published their own work on calculus, and we talked about that quite a bit in last week's playlist. At the start of the 18th century, the ideas and techniques of calculus had been published and distributed across Europe. And mathematicians and scientists had recognized the importance of this very significant advance, and they were both expanding their knowledge of calculus, applying it to new kinds of functions and so forth, and getting facility with it and solving mathematical type problems, but they were also aggressively applying it to solve a lot of scientific problems. Unfortunately, the feud that we discussed in our last playlist between Newton and Leibniz and their students and followers continued through the early years of the 18th century. And this had a very unfortunate result that there became a mathematical schism and even scientific schism between Britain and continental Europe. British mathematicians suffered the most from this divide because Leibniz actually had a better notation for his calculus and because he had the best students. And although the British mathematicians, particularly Gregory and Barrow, and especially Newton, of course, were the original developers and creators of calculus, British mathematics was overtaken by the Swiss-German Leibniz tradition. In particular, at least 6 members of the amazing Bernoulli family, spread out over 3 generations, and their friend and colleague, the great Leonhard Euler, were among the greatest mathematicians of all times, and they were in the Leibniz tradition. They took the lead in expanding calculus and its applications through the 18th century. And this brilliant group was involved in every area of mathematical and scientific advance during the 18th century, of which there were many. Later in the 18th century, there was a group of prominent French mathematicians that included Lambert, Lagrange, Laplace, and Fourier. And these mathematicians further expanded calculus and its uses. They worked in calculus, differential equations, and the calculus of variations, along with applying these areas to optics, mechanics, and other areas of mathematical physics. Among the other advances of the 18th century were advances in mathematical notation. So let's recall that during the Renaissance period of the 15th, 16th centuries, modern notation of Hindu-Arabic numerals and algorithms for using them and operations became well established in Europe. During the 17th century, even more modern notations, including letters for variables, the plus and minus sign for addition and subtraction, the equal sign, and others became standard. Early uses and notations for decimal numbers were introduced in Europe, and the establishment of the Cartesian coordinate system allowed for graphing functions, closer to our modern way we do it. Mathematics was starting to look more like it does today, making the move away from saying equations and expressions in words to using more symbols. So by the time the 18th century started, this trend was well on its way. But this was further continued in the 18th century. In particular, one person in particular, Leonhard Euler, who lived entirely in the 18th century, helped introduce and solidify many of our modern notations. Uh, uh, this just for a few of them. These include the notation f of x for functions, e for the base of natural exponential and logarithmic functions, and many others. After Euler, mathematics looked very much like it still does to this day. Well, in addition to calculus, there were some new mathematical fields established in the 18th century. Several new fields of mathematics were started in the 18th century. These fields continue to provide areas of active mathematical research and application today, and other fields that existed before were expanded greatly in the 18th century and really started kind of founding our modern approach to them. For example, probability theory was established in the previous theory a little bit through the work of Pascal and Fermat and others, but it was expanded significantly during the 18th century. In particular, the English mathematician Thomas Bayes made some important advances in probability in the early 18th century. Laplace also made significant advances in probability. And statistics, closely related to probability, started to become an important area of mathematics as well. Number theory, which goes way back to the ancient Greeks in some cases, saw great advances earlier uh, in the with folks like Fermat and so forth in the 1600s, but in the 1700s we even saw even further advances, laying some foundation for our modern way we look at a lot of number theory. In particular, I want to lift up Sophie Germain. She became one of the most prominent mathematicians of her time, doing foundational work in modern number theory, and she did that despite discrimination based on her gender. Geometry had long been the foundation of mathematics, going all the way back to the ancient Greeks and perhaps even before. And important work in geometry continued throughout the time from ancient Greece all the way to the 18th century. In particular, there's a mathematician, Lambert, came very close to discovering non-Euclidean geometry, and his work laid the foundation for later efforts in this area that continued on into the next century. At the end of the century, some foundational work was laid in the nascent fields of abstract algebra and real analysis, and these fields were to become of great focus in the 19th century and still are today. And in closing, I want to talk a little bit about three mathematical giants. The 18th century included three mathematical giants who lived and worked at least part of the century. All three of these would certainly make anyone's list of the top 10 or probably top 5 best mathematicians of all times. In fact, all three I've seen listed up as contenders for the title of greatest mathematician of all times. When we also throw in that this doesn't include the members of the Bernoulli family and some of the top French mathematicians, together we see that this was an extremely remarkable century for great mathematicians. So the three I want to talk about are Sir Isaac Newton. He lived from 1643 to 1727, so most of his life and work was in the previous century, and especially most of his important work. In fact, the last 2 or 3 decades of his life, he spent his later years in high-paying government positions, and he didn't do nearly the level of work that he did before. So really, most of it, he really belongs with the previous century, and that's where we talked about him quite a bit in our last playlist. But he was the dominant scientific and mathematical figure during the early part of the 18th century. Leonard Euler, lived from 1707 to 1783, living entirely in the 18th century. He was Swiss. He did more important mathematical work than nearly anyone in terms of quantity of high-level mathematics, setting records for the most important papers published. And I think he may either still holds the record for the most published, or if there's anybody ahead of him, there's only one or two people ahead of him. And especially when you look at not only how many he had, but how many of them were very important. It's amazing the quantity of work that he did and its importance to mathematics. We've already talked about how he established much of the notation for modern mathematics. And many of his papers were published after he went blind, and actually many of them were even published after his death. There was decades after he died that folks were working through his notebooks and publishing his work. He's definitely the most significant mathematician of the century if we only consider work done in the century. But there was another young guy at the end of the century that also was a rising star, and that is Karl Gauss. He was born in 1777 and died in 1855. He was German. He was a child prodigy, and he was later to become perhaps the greatest mathematician of all times. Like I said, a lot of people have uh, a, a, a legitimate claim to that, but I've heard many people lift up Karl Gauss as number one. By the end of the 18th century, he had already established himself as a giant in the field of mathematics, with even greater work to come in the 19th century. So we'll talk more about him when we talk about 19th century mathematics, but he was already important in the 18th century. So we'll talk quite a bit about Euler in a later time. Each one of these guys, as well as the Bernoullis, will get their uh, own video. Sir Isaac Newton has already had one in the previous playlist. Karl Gauss will probably save till the next playlist, but Euler will definitely get one in this playlist. So, amazing century with a lot of mathematical growth. Um, and the difference from mathematics from the beginning of century to the end of the century is quite remarkable. And a lot of it was fueled by the establishment of calculus in the previous century.